Okay, so what we'll do today is really to, like we said, we'll start looking at the 3D pictures, right? The 3D flow, how that is different from the axisymmetric flow, and so on and so forth. So what we'll start out doing is try and understand the shape of the cone, right? And then how the flow becomes different if this cone is not axisymmetric and has, the axis of that cone has a certain inclination with the free stream, which is basically the angle of attack, right? So what we'll start out doing is look at the cone. Okay, so what I've tried to do here is draw this cone, right? Draw this cone using a Scilab, okay, so that we can move it around and in space and see how it looks from various angles, so that we will try to have a clear picture, try to visualize the flow. Okay. So I mean that's the best we can do, I guess, in a class like this, in order to visualize a 3D flow. Okay. So all right, so if I'm looking at this here, okay, so I've let me go ahead and do this plot, and we'll see what I'm talking about. So say I plot this, okay, so I get these two pictures here. So let's this is essentially the cone, right? This is a cone which I have plotted here. Now what I'm going to do is, so it depends on the way you look at it. So now say I'm going to rotate this piece and see what we see. So if you look at just the base, okay, if you just look at the base, it is just a circle. If you look at the base, it's just a circle, right? Again, if you say turn this down, this is actually a cone, okay, this is a 3D cone, okay. So let us look at this from say the top, okay. So if I want to look at this, say from the top, what do you think we will see? Well, you should sort of guess by now, right? What do we see here? So it's again just a circle. However, from now if you look at this, this is the apex of it, or the vertex of it, or the topmost portion of it, right? And what you see is essentially a circle. So if you look at it from the top, or if you were to look at it from the bottom, okay, so this is basically the surface, okay, this is what we are looking at. Okay, so now you can, so this is more of a 3D picture now you can see, right? Now let us sort of turn this around a little more and see what sort of this looks like. Okay, now this is something, this is like a wedge. Okay, so you take basically a slice. Okay, so in one of these as I'm moving around the cone, okay, in one of these views I see something like this. It's exactly like a 2D wedge that we have seen so far. So it is something like this. So in the sense, what you should slowly try to visualize, that in certain cases, okay, when we have a flow, right, it is seeing something like this, okay, something like a wedge exactly like this, which is planar, which is 2D, right, and in other cases, okay, it is actually seeing a total surface, a body, call it however you want. Okay, so we have a surface of rotation, and this is a surface, right, and this is what it looks like. So these are, you can see that it is totally two different physical bodies. These are two totally different physical bodies, and these lines here kind of also indicate that basically right, so it's a surface of rotation. So one of the ways you can look at a cone, right, one of the ways you can look at a cone. For example, say, right, so I'm just going to use this in a very crude way. So I'll say this is the axis, okay, this is the vertical axis, which is the axis which is say, right down the from the vertex if you drop a perpendicular. Okay, so say that this is that vertex, right? So then you take a radial line like that, and you take a radial line from the vertex and you move that around. Okay, you move that around, you move that around, move that around, and that forms your cone. So this is your surface of the cone. So you have a conical structure like this. Okay, which, as you can see, although in one of the views that we saw, right, that this did look like, just a triangle, for example, like this. This looks just like a triangle, but it's only one of the views. Okay, so so this is more like it. Okay, now the point is that if I have such a cone, okay, if I have such a cone, and in here I have a free stream which is coming, which is encountering this cone, right? And the free stream direction, let us start with, say, the axisymmetric case which we have done so far. So we have a free stream which comes here, okay, and that is in line with this, with the axis of this, right circular cone. So if you, then what will happen? So in this particular case, okay, when you have a surface like this, okay, and you have a free stream coming in, then obviously there is going to be a shock wave. So the shock wave, okay, is also going to be centered around this vertex, right? But the shock wave is also not going to be the two straight lines which we were sort of drawing so far, which were like the two edges of the, which were like the two sort of edges, okay, of the wedge, so to speak. But here we actually have a surface. So what will happen? So if for the shock wave also we will actually have a surface. Okay, we will actually have a surface which is a conical surface centered around this vertex. So let us see how that would, say, look like. Say this is more like it. So what you see over here is that this structure here, okay, this is the physical cone. Okay, this is the physical cone, this here, and we have a free stream coming in from here, in line with the, in line with the axis of the cone here, and the one on the top, that one on this side, this one that you see here, this is the shock structure. Okay, this is the shock which is encountered. So now let me move this around too. Okay, let me move this around too. Okay, now before I do this, let me plot this one more time. You must be wondering what this is. Let us just take a while and not sort of. I've done this in Scilab, so I can plot it and do it as I want. So let's just look at this now. So we'll come back and see what the other one meant. Okay, so here basically we have the shock structure, right? Sorry, this is the actual physical cone. So what you have here is this physical cone. Okay, now again I'm going to move this around and you can see it for yourself. Okay, now this is what we have been used to so far, isn't it? So we would have, say, a conical, a wedge like that. Then we would draw one line here and one line here, and that would be a shock. Okay, in this case, however, if you look at this, okay, now our body itself, now it appears, right? Now you can see this. Now you can see this. There you go. There you go. Right. So what you see now is that this green thing that you see out here, this is the cone. This is the physical cone, right? This is the physical cone, and the red one out here is the shock structure. Okay, so clearly this is this is the radial line emanating from this vertex. Okay, so this could be, you can say this is the limiting radial line, right. So this will give us the shock wave angle, isn't it? The maximum shock wave angle with respect to the axis, okay, of the cone, which will go, which is a straight line from the vertex up to this base here. Okay. So this is the shock structure here. So what you can see basically, now the major thing is that we move this around and understand how this shock structure looks from sort of various angles. That's why I'm trying to do this here. Okay, because when we do the equations and stuff, we will be encountering theta and phi and z, and we'll we need to be very sure and understand very clearly what all of those mean. Okay, that is why I'm doing all this exercise. Okay, so so what you see in this case, okay, is that now you have a free stream here. Okay, free stream which is coming, encountering this vertex. Now you have a streamline here. So now what you will see here, that when it enters, okay, when it enters this region, okay, when it enters this region, so it is entering a surface of shock. Okay, it's entering a surface of shock, unlike what we have seen before, where we would have just one line, and the streamline would deflect across it. But here, if you were to draw several radial lines, emanating from the vertex, okay, so between the surface, okay, one line would basically go on the surface of this cone, the other on the outer surface of this shock. So between these two radial lines, you actually have a shock surface. Okay, these are not just two lines. You actually have a full, you actually have a full surface, like that. Okay, so now, now the point is, now when we are looking at this, from various angles, so now we will try to understand the sort of geometry over here. Okay, so now if you sort of look at this, okay, so if you look at this, so these are essentially concentric circles. If you look at this, okay, the base of the cone is a concentric circle, is a circle, and the shock wave, I've sort of cut it half so that we can understand, so that we can see. So I mean, it will probably extend a bit longer than I have drawn it here. Okay, so this is also a shock wave. So the way we will look at, okay, so the way we will study or look at the shock properties or changes in the flow properties is basically we will take a sections along this length of the the shock, this cone. Okay, so if I do that, so let me go here and do this. Okay, so if I were to do this, let me call this as, say, this. Am I seeing something here? Okay, I'm not probably seeing something here. Let me go ahead and do this one more time. So say so let me just say, okay, fine. So essentially what I'm doing here is, for example, interesting. So probably sorry. Okay, let's do this here. I think we will get this now. Okay, let's see. So am I getting something here? Why am I not getting this? Okay. Okay, so let me sort of go and look at this. So what I'm basically looking at is just, so now let's go and sort of look at this. Okay, so what I'm going to do here, okay, basically I'm going to run that, the other surface that was doing, so I changed that. Okay, do this, run this. Okay, so what you see over here is this little ring. Okay, that ring is here. So what we will see here is that you can see the small ring there. Okay, so when we are going to study a structure like this, we are going to sort of look at these rings. Okay, look at the geometry of the ring, and in this case, and you can see that this ring is actually going to have sort of the middle portion scooped out, and the middle portion is going to be scooped out when depends on where you are located along this structure over here. So in this case, when you see this, okay, so there is this ring, okay, this ring. So you can just think of a structure like this. Okay, the green portion is a solid cone, is a solid surface cone, and this is a shock structure. This is a shock structure, and both of these have the same vertex. So now what we do is we'll just take this ring, okay, and pass it through this. Okay, so which means that, let me go and pass that ring. Okay, let me go and say pass that ring. See, so I sort of extend that, so I move that ring further down, okay, because I'm going to study this part. So I move that ring further down. So if you look at this, so I got that ring out here. So if I were to look at this, then I would look at the I am in a location like this. Okay, so similarly, so if I were to sort of look at trying to figure out how this geometry would look like. Okay, for example, I move it further down. Okay, if I move it further down, okay, so there you see. So I'm basically passing the ring. I'm passing the ring through this conical structure. Okay, so we have one solid cone and we have a conical shock, okay, out here. Okay, so if that is the case, now let us look at, say, okay. So now if I look at this, so I'm basically looking at a shock, looking at a at a location which is somewhere over here. Okay, somewhere over here. So if I were to look at in say a position like this, if you look at this, all we are seeing is basically one straight line here, another straight line here, a straight line here, and these two wedges. Okay, now this is not any different from whatever we have done so far in terms of oblique shocks and so on and so forth. Okay, we've been drawing these pictures over and over again on the board and in the plane of your notebooks and so on and so forth. Now this is something that this is something that it is actually about. So if you look at this, okay, if you look at this, let us sort of turn this around, move this around and look at this from various angles. Okay, so what I am looking at here is basically this if you look at these three out here, so there's a red circle, there is a blue circle, there is a green circle. So we essentially have three parallel circles, right? We have three parallel circles. So I can also sort of think of this, if you look at this way. Okay, Okay, let's look at it here. So if you look at this, we basically have 3 parallel circles. We have green, this blue, and this red. You can also think of this blue as a section, you know, as a, if I sort of slice, it's almost like I'm slicing this whole thing. Okay, so this shock structure will obviously will be, you know, will extend. I've cut this short here in order to make this a little more visible. So if I were to take this blue, you know, and here and slice it and move it in here, then that's what I would do, and then look at the properties. So you can see therefore that even within the shock structure, okay, even within this red cone out here, which is the shock, okay, it's a shock. So basically this cone also consists of several parallel planes like this. Okay, so I have various parallel planes out here, which is making up the shock cone. Okay, this conical shock structure here. Now if I were to look at all of this, okay, from the base, okay, how would this look like? Make sense, right? This is how it would look like, right? So it's nothing but 3 concentric circles. So if I have to just look at this here, it is nothing but 3 concentric circles. So what you are actually seeing here is this green. So this is when you look at this shock structure through the base. Okay, you're looking at it from the base. So if you look at this, okay, so we have this green part, which is the solid cone. Okay, this is a solid cone, right? And this red part is the shock structure, right? The red part is the shock structure, and this blue is a slice which I have taken anywhere in between the shock structure, in anywhere between, you know, this whole thing. It doesn't necessarily have to be, in a non-shock zone the way it is now, you know. So this is what it looks like if you were to look at it this way. So let's just sort of turn this around and see how it would look like from the other side. Okay, so it helps kind of moving this around and looking at it and trying to understand. Okay, so if you look at this, angle over here, so if you see this, okay, so this is a just think of now just think about this. Okay, now this is a solid cone here, this is a solid cone, okay, and this is the shock structure. So if you have a free stream which comes in here, okay, so you can see when the free stream will come in, a free stream will come here and encounters the shock. It's on a surface. You can look at this. Okay, it encounters a shock like that. So encounters a shock like that. There are no just single straight lines like we have been doing so far. So it will encounter a shock in this way, in a sort of, it will move around in a circle and encounter this, right? And therefore, and then there will be deflections, in those streamlines. So in that case, if I take a slice like that and pass it through this, then I should be hoping to see some property changes in that slice. And then if I put several slices together, okay, and I put all this information together, I might have something to I might have enough information about this whole structure. So if you look at this here, so if you look at this here, okay, now it just looks like that. Obviously, if you're looking at it from the vertex side, okay, if you're looking at it from the vertex side. Okay, so again, just try to take a look at this. It's almost like a hat, isn't it? This almost like the cone is wearing a hat, if you look at this. Okay, so I'm going to turn this around and give you a little bit of view. So if you look at this, so right, so on one view could be, see this straight line, and then you move this around and then you see this. Okay, so you can think of this as a hat, actually, the shock as a hat. Okay, and so when we have a free stream, it is going to it is going to sort of encounter this entire shock structure, okay, and how this is going to behave. So, that is basically our job today. Okay. So, let us again go and sort of try and decipher this geometry part of even a little more. Okay. So, let us look at look at this with a little more detail. Okay. So, this is what we looked at just now, one of the pictures how we looked at it right now. So, let us have this x and y. Now, this x and y, okay, so axis is just in the plane. Okay, you can think of this is just in the plane of the this is the base plane, then this is the plane of the shock, okay, and this is the slice that we were taking. Okay, so this is another sort of ring. So this x y is in that plane, and the z axis is actually a line if you drop from the vertex to the base. Okay. So, if this is true, now what I am going to do here is draw these three sort of radial lines like that. So, these are right now these are three diameters. You can think of three diameters. Obviously, you can see that all these three sections that I am taking, okay, the base here is of a different diameter than the slice blue and the shock base red. Okay. So, these have three different diameters. So, I am basically taking three diameter vectors in that diameter on these three slices, so to speak. Okay. Now, let me rotate this. Okay. Let me rotate this. Okay. So, what we are basically sort of doing here. Okay. So, if you think of this, okay, if you sort of think of this, okay, as the base of the cone, right, if say that this is the base of the cone, right. So, then all we are doing is we have an axis system which is x and y. This is an x and y. This is my axis system, right, and then all I do, this is my axis system, okay, and all I do here is, or just think of the edges. So, this as say x and this is y. Okay, this is the base. You can think of this as the base of the cone, and then you take this diameter axis and move it in this plane. Okay, move it in this plane. So, what you just saw now, okay, what you just saw now, okay, is rotation in these planes. Okay. So, what you can see basically from here is that if you give, if you are rotating it by the same angle, okay, if you are rotating it in this plane, in this conical shock structure out here, you can take any plane. You can take any plane along the z axis, okay, and rotate it by any angle. It will be the same on any plane. If you have an angle of say 30 degrees and you are rotating this diameter say at the base of the cone, it is the same as if you take another plane somewhere here, say near the blue, it will also have, you are basically again rotating it at the diameter here by 30 degrees and or here by 30 degrees. It is the same thing because these are basically parallel planes. Now, if I were to look at, so now this angle is essentially theta. Okay. So, this angle is theta and it is the angle which we are making in the plane, okay, in the parallel planes which are making up the cone shock structure or in the base of the cone, whichever way you want to look at it. Okay. As long as you sort of have a feel for this, it is fine. So, theta is basically the angle that we are making in the plane. Okay. Now, let us look at this. So, what would this look like if I were to just look at this from the base? okay, from the base side. Okay. So, if I am looking at it, so if you remember just now as I showed you, so I have this structure here. Okay. So, so what you can see is if I draw an axis system, is pretty much the same. Okay. It's the same for all the 3 planes that we are looking at. Although here this is the solid cone, the green one, the red is the shock structure, right, and this is a slice somewhere in between, right. But if I take, but these are all concentric circles and these are all centered around the same point. Okay. So, therefore, if I take a radial line here and move it, okay, and I move it, so it is going to make the same angle on all these 3 planes, if you know what I mean. So, theta is essentially giving you just the location in the, you can think of in the xy axis. Okay. So, does not necessarily give you, tell you whether this is a cone or not. So, obviously, we need more information to make this more into a cone. So, what more information do we need so that we can say this is a conical structure? Okay. When I look at it, I know it is a cone, sure, but when I am going to do the mathematics, okay, how am I going to locate a point? What are the things, what are the parameters that we are going to need to locate a cone? Okay. That is the exercise here. So, if I may go back one more time, okay, so what we are looking here is that we have basically taken 3 parallel surfaces. Okay, just for one is the base of the solid cone, another is the base of the shock structure, and just a slice somewhere in between. Okay, and I draw an axis system. When I look at it, in this 3D sense. Okay, so axis system. So these are all concentric circles. Okay, these are all parallel planes. So then I draw these 3 diameter vectors and sort of move them with the same degree in all the 3 planes. So, I see something like this, okay, and this angle what it makes in the plane, okay, is theta. Okay. And as if I look at this here, which in the sort of if I look through the base of the solid cone here, I see a picture like this. In sort of this is like a 2D space. Okay, and then so this is what it will look like if I take a radial line. It's pretty much is just the same radial line moving through all the 3 planes. Okay, so theta basically gives me the location in the xy plane. That's all it does. Okay, so theta. Now, if I go here, okay, now let us look at this structure a little more carefully. Okay, so what I will do is, okay, so this is my xy plane. Okay, so xy is essentially located in the plane of these say green, blue and red. Okay, so if I do that, okay, so I take that radial line. So this is the theta. Okay, so the theta is essentially in the plane, isn't it? So theta is essentially in the plane of the body here, which is the shock and cone. Okay. Now, so let us consider these 3 points. Okay, you see that. So I have taken a point here. So these are 3 different cones, if you can think about it. So this is this point out here. Okay, is a point on the solid cone. This point is on the slice here, and this point is on the shock structure. So these are essentially 3 different points. Okay. Now, what is different between them? What exactly is different between them? Now, if you look here in the planes here, theta is equal to pi, isn't it? It is 180 degrees. It's making 180 degrees with the x axis here, this point. Okay. Now, on this blue plane also, this is making, theta is also making pi. Okay. Again, this is 180 degrees, okay, in the blue plane. And if you look at this blue little blue point here, so this is also making pi in the red surface, right. So, but you can clearly see that these are 3 different points, right, 3 different points. So, what is it, how are we going to define the difference? Because if you look at theta, it's the same in all the 3 planes. Now, what we can do is look at the view from look into, okay. through the base of the cone. If I look at this, so this is this is the shock, this is the cone, and this is the shock. So if I were to look at this 2D space, where do you think the points would be located? If where do you think the points would be located? If you look at this point here, it's at the right, on the leftmost point. So basically this is how the points would be located, isn't it? So for all the 3 planes, if you look at, so all the 3 planes, if you look at this, it's at the leftmost end, so that's where we have this point. If you look at this, it has a leftmost point, which is here, and the red one, again, it's on the leftmost point, which is over here. Okay, so these are the 3 points we are looking at. Now, what we're going to do here, what I've just done, is that I dropped a line. Okay, I dropped a line from the vertex, and reached this point here. Okay, so basically, if you look at this, okay, so this is a plane. Okay, so this is a plane, okay, and I'm looking at, say, a point over here. Okay, so if you look at this, okay, so I have a plane, this is the base of the cone, say, I'm looking at a point over here, right over here. So this makes an angle pi, okay, with the positive x-axis. Okay, now I actually have a cone. Sitting up here. I have a cone sitting up here. So what I am doing is, so I take from this vertex, okay, I drop a radial line which touches this point to reach this point. So I drop a line from here. So that's what this arrow is here. Okay. So similarly, I will drop one more for this point here, for the blue. Okay, that, and then again this. Okay, for this. So what is the difference exactly between these 3? So essentially what I am looking at, this is essentially a cone structure, isn't it? So at the base, okay, so at the base I have this point, okay, right, and the cone then sort of, it comes up like that. Then you have a blue, okay, a blue structure there, okay, in here, and the way the shock structure here is that the shock has a larger, the shock base has a larger diameter, and that sort of decreases. The cone has a smaller diameter compared to the shock. Okay, so therefore I have a point here. Okay, so and the next point is somewhere over here. So for the first one, I drop a radial line from here like that, and for the next one, I drop a line like that. Okay, like that, and for the third one again I drop a line from here, and it will probably reach there. Okay, so that is what I have done in this case. So if you want to think about it this way, so here, okay, so you can think of this, okay, for this particular point. So if I have this sort of vertical axis, okay, so for this particular point, okay, so I have this angle. So if you look at this, this radial line makes a certain angle with this vertical axis. Now the next point is somewhere over here. So then this has to move like that, isn't it? This is the next point. You can think of this as the blue plane. Okay, so this angle is what it is making with the vertical. Again, for the shock, it's somewhere over here. So I have to increase the angle. So this is the surface in which I am acting. So when I am drawing these radial lines, it is in this this place. Okay, and the angle which it has made with in this particular plane is theta, which is in this plane. So if you do clockwise or anti-clockwise rotation here, and this rotation is in this plane, which is, this plane is actually perpendicular to the plane in here. Okay. So if I were to sort of look at this, okay, let us look at this from another angle. Okay. So you can see here now, this is my cone, this is the cone base, okay, this is the shock structure up here, and you have this cutting plane somewhere over here. So then these are my 3 points, isn't it? We located these 3 points somewhere over here, okay. And then if I drop a perpendicular from the vertex, okay, to the base of the cone, okay. So in this plane, in this plane actually, plane of these concentric circles over here, this is the theta, okay, and you can see the theta is equal to pi for all the 3 cases. Then, okay, so you have this, like I just now tried to show you. So this say I have this vertical, okay, I have this vertical, and then I lift it, okay, lift it so that it is this radial line basically gives me this particular point, okay. This radial line is being originating from the vertex. Similarly, let us try and look at this point here on the blue plane. Okay, so you move that and it goes that way. So again we take this and we move this, so then again it goes. So essentially we have, okay, 3 radial lines, okay, and this angle that it makes, okay, is the angle phi, okay. This angle is the phi angle or the azimuthal angle, okay. So if now we located, for example, so these 3 points right at the edges, okay. So now okay, sort of, okay, so what we looked at, okay, so now we looked at, we took 3 points exactly on the left, at pi, basically theta is equal to pi. Now what if we don't do that? What if we take different points? So now let us look at each circle here or plane here. If you look at the green place here, okay, this is not pi degrees, okay, it is less than pi, it is something less than pi, okay. So it could be 150 degrees, for example, okay, and this one is pi. On the blue plane it is still pi, right, it is still pi. And if you look at the red plane, okay, now this is more than pi, isn't it? If you look at just the red plane, it is more than pi. So it would probably be 180 degrees, plus 30 degrees or plus 45 degrees, probably not 45, maybe 35 degrees, okay. So pi plus 35 degrees, okay. So we have this. Now in this case, how will this if I were to drop the the radial lines from the vertex, how will they look like? Okay, so what this means is that I have this radial line, okay, I have this radial line, and then I move it here, okay, look here, okay, then I do that and I move it here, so that moves there, then move here, okay. So if I were to sort of, what exactly am I doing here, okay. So in the previous case we said we are looking at basic, so again this is the base of the cone, right, again this is the base of the cone, and say this is the point that we are looking at, okay, this is the point we are looking at. So there are 3 points, okay. So then at the first instance I have a it is just a straight line. So you can the first instance is just a straight line along the body of the cone which reaches here, so that you can just take that as the surface of the cone, so that comes up here, okay. So you can also think of a radial line, okay, which you drop. So radial line is here and you basically point it to the to this particular point. Now the next radial line should look at, is the point which is higher up here. So we went like this. So this was our next point, okay, this was our next point, and the third one again it went up here. So these are the 3 points that we located, okay, and all the 3 points here were at the left, or theta was pi, okay. Now theta is not pi, okay. For the first one, what I am locating is a point somewhere over here, okay, it is making less than pi, okay, it is actually like making less than pi. So, if you look at it, the point is here actually, the point is here, isn't it? So, in that case, so first if I drop a perpendicular, so in the previous case I drew the perpendicular, my radial line was here. Now, the radial line is going to shift by this theta. Okay. Again, previously when I had this radial line, okay, now for the next one, okay, which is for the blue one. So, if I have this, okay, previously what I had was like this. Okay. Now, it is going to remain at the same point because still theta is pi. Okay. So, this is still going to remain at the same point. And the third one, again, previously again it was here in the same plane. Now, that is going to move, it is going to be here. So, hopefully you can see the difference. Okay. Hopefully you can see the difference. So, that is the theta which is creating the difference. So, essentially, so I have this vertical, okay, which I am dropping from the vertex. Okay. So, I have, say this is the point which I am located. So, point at this point at this particular location, it is in this plane is making pi degrees. Okay. What if it makes more than pi? So, then I am going to just track the particle, I am going to track the particles, I am going to go behind. So, say the particle is moving, so I track it, so I track it, I move this, okay, move this, now it is making 0 degrees. So, then I move it, then I move it, then that forms my cone, okay. That forms my cone, and you can see it is still the same radial line. Okay. It still makes the same angle with the vertical, so to speak. It still makes the same angle with the vertical. Okay. Still makes the same angle with the vertical, but because this point is now moving in this xy plane. Okay. So, the theta is changing, so this also moves, but the phi remains same. Okay. The phi remains changed, but because of the theta changing, this moves. So, that is what essentially these radial lines are mean over here. So, if you again if I sort of look at this, okay, so I am looking at these 3 points, okay. So, this goes up by radial line, okay, that and this again if I look through the if I look sort of into the cone structure through it, okay. If I look at this, then in this particular case, what would you notice, right? So, if now you can see that in this plane, okay, in this plane, these are 3 concentric circles, but if you look at just the green circle here, which is the base of the cone, okay, it is making less than pi. Isn't it? It is making less than pi. This is again at pi, the theta, and the blue is more than pi. Okay. So, you can see it from here. Okay. So, so essentially when now, and of course, another difference is that this is also at a, so besides just the height, besides just the angles, okay, now we are able to sort of locate this, okay, not only just in the plane, but also not only just in this plane, okay, the x axis, but also in a conical plane like this. But whether we have the base of the cone or we have the slice here or we have the base of the shock structure is again going to be decided by the height z. Okay. So, that information is also necessary. So, I think we will stop here right now, okay, and then when we take it up from here, again what we will start doing is now go ahead and try and understand the difference between the axisymmetric and symmetric case of the shock structure. Okay. So, we will stop here now and take it up from here. Okay. Thank you.